Properties of exponents. Quotient properties. Before we start, I want you to take a second and think about this word here, quotient. What does it remind you of? What should it remind you of? Fractions, ratios, okay? Something where there's a numerator divided by a denominator. And sure enough, if you look at our first example, we have a fraction, okay? So, the instructions say to simplify the following expression. We're going to show this by expansion. Okay, so we know how to expand because from the previous lesson, we learned that this power is saying that C needs to be multiplied 5 times in the numerator. In the denominator, C needs to be multiplied twice. Now before you think, okay, I'm done, that's it, there's nothing else to do, think about things you've learned through the years about math. When we have a fraction, a number over another number, there's something that you might have forgotten and it's needed at this moment. C in my denominator with the same C in the numerator reduces to 1. Okay, so you're probably wondering why. So let's see. Let's look at this example. 5 divided by 5, 1. 13 divided by 13, 1. 1,876 divided by 1,876, 1. So we can say that any number, x, divided by that same number, x, will always reduce to 1. So I'm applying this in my problem here. So I have another c in my denominator that can be reduced with another c in my numerator, and that reduces to 1. So in the end, I'm going to simplify and write my final answer. Now, I have no more c's in my denominator because they were reduced. So there's no need to write this fraction bar. Instead, I'm going to write the 1 that I have from here times the other 1 times c, and c 3 times. Now, this can still be simplified a little more. So if we apply the associative property that we learned before, where I can group those two, and those two are multiplying, then I just get 1c cubed. But really, in math, there's no need to write that 1 there. So then this would be our simplified answer. Now you might be thinking, okay, I'm seeing a pattern here. This 3, is it associated to those two powers there? 5 and 2. How do I get a 3? Maybe I subtract. We'll hold off to that thought. Let's try a different example. So here we have g cubed h to the 5th divided by g h squared. So I'm going to expand. Okay, so I expanded my problem. And again, I'm going to apply the same rule of division. When we have a number in the denominator that is equally the same in the numerator, that reduces to 1. So no more g's to reduce, but I could reduce h's. A 1 there and a 1 there. So that's it. Nothing else to reduce. I'm done. So I'm going to rewrite this a little neater. So I don't have anything remaining in my denominator, so no need for a fraction bar. What I do have, though, is this 1 times 2 g's, so g squared, times 1 times 1 times 3 h's, so h cubed. Now remember we learned the commutative property which said just rewrite things. It's more pleasing to the eye, so I'm rewriting it. Commutative property said group them, put them together in a group. So I can group my 1s, 1 times 1 times 1, well all of that is just 1. G squared, h cubed. But again, there is no need to write that 1 there because we know that it's there. It's a rule of math. Therefore, our simplified answer is g squared h cubed. Okay, so again, you might be thinking, oh, well, I see the same pattern, miss. This too, I could have gotten it from this cube and this g. This 3, I could have gotten it from this 5 and this 2. Well, that brings us to our first property, quotient of powers. To divide when two bases are the same, you're going to write the base and subtract. And that is exactly what you were thinking. Subtract their exponents. So what this is saying is, let's say you have this power divided by this power. Since their bases are the same, I'm going to keep the base in my answer, but I'm going to subtract the exponents. And that's all it is. So instead of expanding it like we were doing earlier, we're going to apply this rule. Only if it's division and only if the bases are the same. So here we go. Next example. So we have this fraction here with two types of variables, x's and y's. What I'm going to do first is I'm going to split this up because in fractions, things are neater when they are split up. So I'm going to apply that. X is in one fraction, y is in a different fraction. Now the reason I did this is because this way we can see that this is division, they have the same base, so I can use the quotient of powers, which says, hey, subtract the powers. Same thing with the y. Same base, the numerator is y to the fourth, the denominator is y to the power of 1, so 4 minus 1, and now we can simplify our answer. So this is x, 3 minus 2 is 1, 2x to the 1, and y, 4 minus 1, y cubed. Now again, this 1 is not necessary, so this will be our final answer, our simplified answer. Pretty easy. Easier than expanding. Let's try a different example. So here we have this crazy fraction. It may look confusing, but again, the best thing to do is split things up in fractions. If we can split components up, maybe it'll make more sense. Okay, so I had to split things up. Next, I'm going to use the quotient of powers property, which says, if they have the same base, subtract the exponents. When this first fraction, I cannot subtract them because 25 is not the same thing as 5. They're not the same base. So I'm going to leave the fraction the way it is. My case, however, I can subtract the powers. Same thing for my m. Same thing for my p. Just don't forget, this p in the denominator has a power of 1. So therefore, I subtract 1. Time to simplify the answer. Now, we were not able to subtract those two, the exponents, but what we can do is divide them. 25 divided by 5 is 5. This is k to the power of 2, m to the power of 7, and p to the power of 3. This is a simplified answer. It's a lot easier than expanding. Of course, if you want to expand, you can expand, but it's going to take a lot more time. Just apply the rule. Next one, power of a quotient. The power of a quotient is equal to the numerator raised to that exponent divided by the denominator raised to that same exponent. So what in the world does this all mean? Okay, so we have a quotient. So we have, let's say, a divided by b, or 7 divided by 8. Let's suppose this was raised to the power of n. This is raised to the power of 2. What it means is this is the same thing as a raised to that exponent and b raised to that exponent. In other words, 7 squared and 8 squared. They each get the same exponent. That's all it is. Numerator gets the exponent, denominator also gets the exponent. So let's apply it in a similar problem. So, simplify the following expressions using the power of a quotient property. We just learned that the property says when we have a quotient of a power, we can split it up to where the numerator gets that power, but guess what? So does the denominator. Okay. But now, of course, this problem has an extra step. Now we have this situation here. Now think, this looks familiar. We just did something like this. Don't pay attention to the denominator. Let's pretend that wasn't there. The numerator, that looks similar. So if you think this, then it's because you are correct. This is the power of a power, which told you that you can multiply the exponents. So I'm going to do it to my numerator and to my denominator. And then I can simplify. So now I have x to the 4 times 5, which is x to the 20th, divided by y to the 2 times 5, which is y to the 10th. Now before you think, okay, let me subtract this exponent with this exponent, let me stop you right there. Because this x and this y do not have the same base. So do not subtract the exponents. This is our final answer. That's it. Nothing else that we can do. Okay. Next problem. We have this quotient raised to the power of 3. So what we're going to do first is kind of like distribute the exponent. So basically every coefficient, every variable is raised to the power of 3. Now we're going to apply the power of a power property. So this is 2 to the 1 times 3, because 2 has an exponent of 1. Then it's m to the 3 times 3, 4 to the 1 times 3, and n to the 1 times 3, because n currently has an exponent of 1, so does a 4. Okay, so now let's simplify. Okay, so I multiply what I could. Now before we say this is our final answer, this needs to be simplified because we know what n cubed is. And we know what 4 cubed is. 64. But I know you're thinking, oh, I'm tired of this problem. Just one last thing. Can this be reduced 8 over 64? And the answer is yes. Yes, it can. 1 over 8. But let's not forget the m and the n. And of course, the 1 does not have to be there. So this would be our final answer, our final simplified answer. Okay, a little long, I know. Next one, simplify the following expression, again by expansion. You're probably thinking, oh, this looks like the one we just did. Okay, so let's expand. Some of you might be thinking, okay, I don't want to expand. I just learned that if the bases are the same and it's division, I can simply subtract the powers. And you are correct, so let's just use what we learned. 3 minus 7, negative 4. And then you're thinking, that's it, miss, I'm done. And the answer is, nope, you're not done. We cannot leave our answer with a negative exponent. So what do? Okay, that's why it's important to expand. So let's go ahead and expand. So we expanded, we're going to reduce, that's 1, that's 1, that's 1, nothing else to reduce. So let's see. In our denominator, we have 1, 2, 3, 4 h's, so h to the 4th. In our denominator, no more h's. We have 1 times 1 times 1, 1. So this is our final answer. How does this end up like this? Well, that brings us to this property, the negative exponent property that says any non-zero number, so any number as long as it's not 0, raised to the negative n is a reciprocal of a to the n. So what does that mean? Well, when you have a negative exponent, you're going to have to take the reciprocal. So flip it. So if this was a fraction, it would end up looking like this. Except we no longer need the negative. So this would be the reciprocal of it. Okay, so let's try it. Let's apply the direct rule. Let's not expand, because yeah, it takes too long. So the first thing I'm going to do is split these two up. We just learned that when it's division and bases are the same, we can subtract the exponents. So g to the 3 minus 7 is g to the negative 4th. H to the 6 minus 4, that is a positive 2. So we have to do something about this, because it cannot stay like that as your simplified answer. What's going to happen is we're going to turn that into a fraction, and it's going to flip. When we flip, we no longer have a negative power. But since we turned this into a fraction, this also has to be a fraction. But it's not flipped, because it doesn't have a negative power. So what happens when we have these two fractions? Okay, well, h squared times 1 is h squared. So I'm going to write my answer up here. 1 times g to the 4th is just g to the 4th. And this is our final answer. Okay, so what I'm going to do is I'm going to expand it here on the side so you can see this, how it works. So there you go, it's expanded. I'm going to reduce 1, that's 1, that's 1, that's 1. Then my h's, that's 1, that's 1, that's 1, and that's 1. Nothing else to reduce. So in the end, we have 2 h's as my numerator, and we have 4 g's in my denominator, and that's our answer. Now you might be thinking, well, isn't it easier to just expand? It is, but sometimes you're going to get really, really large exponents, and it's going to take too long, so it's better to just apply these rules. So let's try another one. This problem has a little bit of everything. So what we're going to do first is this here. Take care of that. Power of a quotient said, when you have a quotient raised to an exponent, every single little thing gets raised to that exponent. So that's what I did. Next, I'm going to use the power of a power, and I'm going to multiply exponents. Okay, so I went ahead and multiplied them, and this was the result. Next, I'm going to use the quotient of powers, which means subtract the exponents. Okay, so again, I'm going to split this up because it looks nicer like that. The 4 and the 3, not the same base. My h, I have a negative 16 minus a 4, and my k, well, is just k squared. So I'm going to simplify. This could actually be simplified to 16 over 9. Then we have h to the negative 20, and then we have k. Nope, that didn't fit. So I wrote it over here. Okay, so again, this is not our final answer because of this. You cannot have a negative exponent. So if I make it into a fraction and I flip it, then I end up with this answer. That doesn't change. This changed. And this, since it wasn't a fraction, let me just put a 1 under it, so it could look like the rest. So this whole mess is what we want, because now h no longer has a negative power. We flipped it. So the final answer, to make this look a little nicer, will be 16 goes in the numerator, k squared goes in the numerator, 9 goes in the denominator, h to the 20 also go in the denominator. Those extra ones that you see, numerator and denominator, we don't need them. We don't have to write them. So now this would be our final answer. Tough problem, I know.